When sizing conductors for a 100 amp subpanel in a detached garage of a single-family dwelling with a single-phase 120/240 volt system, the appropriate table to reference is Table 310.15b6 of the National Electrical Code, or NEC. Table 310.15b6 provides specific ampacity requirements for service entrance conductors and feeder conductors for individual dwelling units. It permits the use of reduced ampacity for specific conductor sizes based on the overall load calculations. The primary reason for using Table 310.15b6 rather than Table 310.16 stems from the NEC allowance for reduced ampacity in dwelling unit service and feeder conductors. This reduction acknowledges the diversity of loads typically found in residential settings, where not all appliances and electrical devices operate simultaneously at their maximum rated current. Table 310.16, on the other hand, provides ampacity ratings for conductors in general applications and does not incorporate the specific rating factors applicable to dwelling units. To accurately size conductors for the 100 amp subpanel using Table 310.15b6, firstly determine the total calculated load for the garage subpanel. This involves summing up the anticipated loads from lighting, receptacles, power tools, and any other equipment that will be connected to the subpanel. Accurately calculating this load is crucial for ensuring the conductors are adequately sized to handle the expected current draw. Secondly, once the total calculated load is known, consult Table 310.15b6 to find the appropriate conductor size for a 100 amp rated panel. This table typically provides ampacity values for copper and aluminum conductors based on specific insulation types and temperature ratings. Note that the table provides ampacity ratings for specific conductor sizes, which may allow for a smaller conductor size than would be required by Table 310.16 for a 100 amp load. Thirdly, consider any applicable rating factors. While Table 310.15b6 already allows for a reduced ampacity, additional rating factors may be necessary based on the specific installation conditions. For example, if the conductors are run in conduit with other current-carrying conductors, or if they are exposed to high ambient temperatures, the ampacity must be further reduced in accordance with NEC guidelines. Fourthly, select the appropriate conductor insulation type. The insulation type of the conductor affects its ampacity rating. Common insulation types include THHN, THHW, and XHHW. Each insulation type has a specific temperature rating, which determines its ability to withstand heat. Choose an insulation type that is suitable for the installation environment and meets the requirements of the NEC. Fifthly, ensure proper overcurrent protection. The subpanel must be protected by an overcurrent device, such as a circuit breaker or fuses, rated at 100 amps. The overcurrent device must be sized to protect the conductors from overload and short-circuit conditions. The conductor ampacity must be equal to or greater than the rating of the overcurrent device. Sixthly, ground the subpanel properly. Proper grounding is essential for safety. The subpanel must be grounded to the grounding electrode system of the building. This ensures that any fault current will safely return to the source, tripping the overcurrent device and preventing electrical shock hazards. Seventhly, use appropriate wiring methods. The wiring method used to install the conductors must comply with the NEC. Common wiring methods include conduit, cable, and direct burial. Choose a wiring method that is suitable for the installation environment and provides adequate protection for the conductors. Eighthly, comply with all applicable local codes and regulations. In addition to the NEC, local codes and regulations may impose additional requirements for electrical installations. Check with the local authority having jurisdiction to ensure compliance with all applicable codes and regulations. Ninthly, consider future load growth. When sizing conductors, it is important to consider potential future load growth. If it is anticipated that the load on the subpanel will increase in the future, it may be prudent to install larger conductors than are currently required. This will avoid the need to replace the conductors if the load increases. Tenthly, document the installation. Keep a record of the conductor sizes, insulation types, wiring methods, and overcurrent protection used in the installation. This documentation will be helpful for future reference and for any necessary maintenance or repairs. In summary, Table 310.15b6 allows for a reduction in conductor size for dwelling unit service and feeder conductors based on specific criteria outlined in the NEC. Always consult the latest edition of the NEC and local codes to ensure compliance with all applicable regulations. The requirements in Table 310.15b6 are designed to provide a safe and reliable electrical system for dwelling units while also allowing for some flexibility in conductor sizing based on the anticipated load diversity. This table is specifically applicable to single-family dwellings and similar residential applications where the load characteristics are well understood and the potential for simultaneous maximum load is limited. By adhering to these guidelines, a safe and compliant electrical installation can be achieved for the 100 amp subpanel and the detached garage. Understanding the nuances of the NEC and its specific provisions for dwelling units is crucial for electrical professionals and homeowners alike. Correct application of the NEC not only ensures safety but also contributes to the overall efficiency and reliability of the electrical system. When working with electrical systems, always prioritize safety and consult with qualified professionals when necessary. The NEC is a complex document, and its proper interpretation requires expertise and experience. Never attempt to perform electrical work unless you are properly trained and qualified. Using the correct ampacity table ensures that the conductors are capable of safely carrying the anticipated load without overheating, which could lead to insulation damage or even a fire. The NEC provides specific guidelines for calculating the load on a subpanel, including demand factors that account for the fact that not all loads will be operating simultaneously. These demand factors can significantly reduce the required conductor size, especially in residential applications where there is a high degree of load diversity. Considering the ambient temperature is crucial because higher temperatures reduce the ampacity of conductors. The NEC provides correction factors for adjusting the ampacity of conductors based on the ambient temperature. These correction factors must be applied to ensure that the conductors are capable of safely carrying the load at the expected operating temperature. Furthermore, the number of current carrying conductors in a raceway or cable affects the ampacity of the conductors. When multiple conductors are bundled together, they generate more heat, which reduces their ampacity. The NEC provides adjustment factors for directing the ampacity of conductors based on the number of current carrying conductors in a raceway or cable. The terminal temperature ratings of the equipment connected to the subpanel must also be considered. The NEC requires that conductors be sized based on the lowest temperature rating of the terminals or the conductor insulation. This ensures that the conductors are not overloaded and that the connections remain safe and reliable. Grounding and bonding are essential for safety in electrical systems. Grounding provides a path for fault current to return to the source, tripping the overcurrent device and preventing electrical shock hazards. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electric shock. The type of wiring method used to install the conductors affects their ampacity. Some wiring methods, such as conduit, provide better heat dissipation than others, allowing for higher ampacity ratings. The NEC provides specific guidelines for the ampacity of conductors based on the wiring method used. Overcurrent protection is essential for protecting conductors from overload and short-circuit conditions. The overcurrent device, such as a circuit breaker or fuse, must be sized to protect the conductors from damage. The NEC provides specific guidelines for the size and type of overcurrent protection required for different types of conductors and applications. Voltage drop is another important consideration when sizing conductors. Voltage drop occurs when the voltage at the load is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction and can reduce the efficiency of the electrical system. The NEC recommends limiting voltage drop to a maximum of 3% for feeders and 5% for branch circuits. When using Table 310.15b6, it's vital to understand that it's not a blanket permission to undersize conductors in all situations. The specific wording of the code must be carefully examined to ensure that all conditions for its application are met. For instance, the table typically applies only to the main feeder conductors supplying the entire dwelling unit load or to specific portions of the load as defined by the code. It is not intended for general-purpose branch circuits within the dwelling unit. The ampacity values listed in Table 310.15b6 are based on specific conductor sizes and types. These values may differ from the ampacity values listed in Table 310.16, which is used for general-purpose applications. When using Table 310.15b6, it's essential to select the correct conductor size and type to ensure that the ampacity meets or exceeds the calculated load. Furthermore, the overcurrent protection device must be sized to protect the conductors in accordance with the NEC. The overcurrent protection device must not exceed the ampacity of the conductors, and it must be sized to provide adequate protection against overload and short-circuit conditions. In addition to the NEC requirements, local codes and regulations may impose additional requirements for electrical installations. These local codes and regulations may be more stringent than the NEC requirements, and it's essential to comply with all applicable codes and regulations. When in doubt, it's always best to consult with a qualified electrical inspector or engineer to ensure that the electrical installation meets all applicable requirements. They can provide guidance on the correct application of the NEC and local codes and regulations, and they can help ensure that the electrical installation is safe and compliant. Remember that electrical work can be dangerous, and it's essential to take all necessary safety precautions. Always disconnect the power before working on electrical equipment, and use appropriate personal protective equipment such as gloves and eye protection. If you're not comfortable working on electrical equipment, it's best to hire a qualified electrician to do the work for you. They have the training and experience to perform electrical work safely and correctly. By following these guidelines, you can ensure that the electrical installation for the 100 amp subpanel in the detached garage is safe, compliant, and reliable. Always prioritize safety and consult with qualified professionals when necessary. The National Electrical Code is updated regularly, so it's important to stay current with the latest requirements. The NEC is available for purchase from the National Fire Protection Association, and it's also available online through various subscription services. In addition to the NEC, there are many other resources available to help you learn about electrical safety and best practices. These resources include textbooks, online courses, and training programs. By taking the time to educate yourself about electrical safety, you can help prevent accidents and injuries. Always remember that electricity is a powerful force, and it must be treated with respect. By following safe work practices and complying with all applicable codes and regulations, you can help ensure that electrical installations are safe and reliable. The proper selection and installation of conductors is crucial for the safe and efficient operation of electrical systems. By carefully considering all of the factors discussed above, you can ensure that the conductors are sized correctly and that the electrical system is protected from overload and short-circuit conditions. Furthermore, regular maintenance and inspection of electrical systems are essential for identifying and correcting potential problems before they lead to accidents or injuries. By performing regular maintenance and inspections, you can help ensure that electrical systems remain safe and reliable for years to come. Ultimately, the goal of electrical safety is to protect people and property from the hazards of electricity. By following safe work practices, complying with all applicable codes and regulations, and performing regular maintenance and inspections, you can help achieve this goal.